Question number 21. The particle P shown in figure has a mass of 10 mg and a charge of minus 0.01 microcoulomb. Each plate has a surface area 100 cm square on one side. What potential difference V should be applied to the combination to hold the particle P in equilibrium? So here, weight of particle, so suppose we write it as F, so that will be mg, and this must be equal to electric force QE. So we can write it further, mg equal to, and since electric field is V upon R or V upon D, so we can write it as Q V upon D. Now further, we can write it as mg equal to Q V, and this D can be replaced by using the formula of capacitance, C equal to epsilon naught A upon D. So we write it here. So this will become C divided by epsilon naught A. Now our concern is to find out V. So V equals mg times epsilon naught A divided by 2 times C. We put the values. So M is given as 10 mg. So 10 times 10 power minus 6 into G is 10 multiplied by epsilon naught 8.85 into 10 to the power minus 12 times area of the plate. So 100 centimeter square, that is 100 into 10 power minus 4, whole divided by charge on plate, charge on the particle, that is minus 0.01 microcoulomb. So 0.01 into 10 to the power minus 6 into capacitance. Capacitance is given as 0.04 microfarad, so 0.04 times 10 to the power minus 6. If we simplify, we will get V equal to 43 times 10 to the power minus 3, which is our answer. Now, question number 22nd. Both the capacitors shown in the figure are made of square plates of edge A. The separation between the plates of the capacitors are D1 and D2 as shown in the figure. Potential difference V is applied between the points A and B. An electron is projected between the plates of the upper capacitor along the central line. With what minimum speed should the electron be projected so that it does not collide with any plate? Consider only the electric forces. So electron is projected from here and its trajectory is shown. This separation is D1, this separation is D2. These are the points from where potential is being applied. Now, we can consider the motion along x-axis. So x equal to ut. Here, this distance is given as a. So we can say a equal to ut or t equal to a upon u. Now, distance moved along y-axis. Since this is halfway, it means this distance will be, vertical distance will be d1 by 2. So applying formula, s equal to ut plus half at square. So y equal to 1 by 2 at square, which is equal to d1 by 2, 1 by 2a, f equal to ma equal to qe. So from here, a will be qe upon m. So 1 by 2 qe upon m times t square, and time is a upon u. So this will become a square upon u square. Now, since both the capacitances are in series, so equivalent capacitance will be equal to C1 into C2 divided by C1 plus C2. So we put the capacitances. So epsilon naught A square, which is area of the plate, divided by D1 times epsilon naught A square divided by D2 whole divided by epsilon naught A square divided by D1 plus epsilon naught A square divided by D2. Now, if we further simplify, we will get epsilon naught A square divided by D1 plus D2. Now, total charge supplied by the battery, Q equal to C equivalent times voltage. C equivalent, we have got epsilon naught A square divided by D1 plus D2 times voltage is V. Now, we find potential difference across first capacitor, which will be equal to V1, which is charge on it divided by its capacitance. So charge is this much. Since capacitances are in series, so charge will remain same. So epsilon naught A square V divided by D1 plus D2 times C1, and value of C1 is epsilon naught A square divided by D1. So from here, we get V1 equals V times D1 divided by D1 plus D2. Now we find electric field inside the capacitor. So electric field E equal to V1 upon D1. So here voltage applied, we have got V1 as V D1 divided by D1 plus D2. So V D1 divided by D1 plus D2 times D1. So D1 will cancel out, and we will get V upon D1 plus D2. Now, we have already got the equation D1 by 2 equal to 1 by 2 QE upon M times A square divided by U square. So we can take help of this equation. So we write D1, 2 will cancel out. So D1 equal to QE upon M times A square upon U square. And we put the value of E, V upon D1 plus D2. So Q upon M A square upon U square times V upon D1 plus D2. Now, we separate U square because our purpose is to find out the speed U. So it will become U square equals Q times A square V divided by M times D1 times D1 plus D2. Here this D1 will go in denominator, and there is already D1 plus D2. So our concern is to get the value of U. So U will be square root of this. So that is, we can say Q times A square V divided by M times D1 times D1 plus D2 whole power half. So this is our answer. Thank you for watching.